In this video, I introduce overfitting problems in artificial neural networks. One key terminology in machine learning is a generalization, namely a model is trained on a training dataset and should be generalized to unseen samples during the model training. Overfitting is the most common problem in machine learning, which occurs when a model accurately predicts samples in the training dataset but not unseen samples. The reasons for overfitting may be first, the training dataset is too small, or the diversity of his samples is not enough to represent all possible samples. Second, training is too long on a small number of samples. Third, training dataset contains many noisy samples. And last, the model complexity is high, so it learns much noise or irrelevant information within the training data. Overfitting can be detected by testing a model on unseen samples, since an overfitting model has a low error rate on the training dataset, but it has a high error rate on unseen samples. When we try to avoid overfitting through enlarging training dataset or reducing the model complexity, we may have an opposite problem, namely underfitting. Underfitting occurs when a model is not trained for enough time, or the training samples are not enough to determine a relationship between the input samples and the corresponding output labels. Both overfitted and underfitted models cannot reflect the dominant trend of samples in the training dataset, so that they cannot be generalized to unseen samples. Different from overfitting, underfitted models experience a high bias and less variance within their predictions. We need to trade off bias and variance to find a good machine learning model. With the procedure of model learning, the bias reduces by updating model parameters, but the variance increases due to more samples involved. The goal is to find the balance between the underfitting and overfitting so that the learned model can establish a dominant trend to fit to unseen samples. Underfitted models generate a high error rate on both the training dataset and unseen samples. However, overfitted models generate a low error rate on the training dataset, but a high error rate on unseen samples. One easy way to detect if a model is overfitting is to use the holdout of a dataset. Namely, the model cannot observe the samples in the holdout during training. And the holdout is used as unseen samples to test the performance of a trained model. The most common method to reduce overfitting of machine learning models is to enlarge the scale of a training dataset, perform data augmentation, use dropout, and reduce the model complexity. In addition, there exist more techniques to improve the overfitting problems, such as early stopping, feature pruning, and regularization. For more details, please check with these references. Thank you. Bye.